All right, today we'll talk over what to expect on your test. Our fifth unit, which happens to be chapter 10 on our Think Well material, and using the definite integrals in certain applications is pretty much what we've been looking at. There will not be 20 problems on the test. I do want you to get done tomorrow. Let's see, there are 12 problems. And as I was kind of thinking through what types of problems we have, there's really three main types we've been looking at. One, the acceleration, velocity, and position. And then kind of a subset of that would be solve the differential equation. You're essentially doing the same operations as your acceleration, velocity, and position, but solve differential equation, say if your second derivative of x is x squared, and then you know something about then solving the differential equation, you're really going through the procedure that you do with the given acceleration, find your position function, integrate a couple times, and then these function values, derivative values, will give you the constants. You'll be able to find the exact constants. So that's one type of problem, basic type of problem. Then the second basic type of problem is find the average value of a function. And what's the formula for that?
You take 1 over
Okay, and essentially the integral turns out to be your area under the curve, and then times the 1 over b minus a. So, and we didn't do a whole lot with that, but you might have one problem like that on the test. You probably would rather have 10 of them like that. But
So we have to find the x and y values for that function?
in this case, I'm going to just limit it to the average value. In the worksheet, they ask you to find the x value where that would occur. But for this, I'm just going to limit it to the average value. So. And then finally, the last part, which was most of this unit, finding the area for a given region. And most of that turned into a big ugly algebra problem. We do a tiny bit of calculus, but most of it's the algebra. So 12 problems, all of them will fit into one of these categories. Now, we'll kind of look at some detail here with each part. Acceleration, velocity, and position. We did look at a lot of different setups for that, and we'll kind of talk through some. A lot of these problems we were given the acceleration, or perhaps it's called deceleration. What's the difference between acceleration and deceleration?
One is a negative.
Okay, the deceleration would actually be a negative value. So maybe a car is decelerating at a certain rate. Well, we could say it decelerates at 20 miles per hour, feet per second, meter per second, whatever the rate turns out to be. But any time, let's see, the acceleration, if it's positive, the acceleration is increasing. If it's negative, the acceleration is decreasing. Velocity, what does a negative velocity mean?
So you're going in the opposite direction.
Okay, it's going in the, well, yeah, opposite direction, negative direction. We saw that a little bit more with the vertical motion. Going up or down, negative velocity means the object is going down. So once we are given the acceleration, your velocity, well, it'll be your antiderivative, okay? And then usually we're given some information where we can find the constant. Maybe the object, let's take for instance an object being going through the air vertically, falling through the air. If it is thrown down at a rate of 10 whatever meters per second,
And you said equal to 10 meters.
thrown down,
0.
v of 0 would be what then?
10 of 10.
Thrown down,
Negative 10.
negative 10.
Yeah.
Thrown up would be positive, and what if it is just dropped?
Zero. Yes, sir.
Okay, the initial velocity would equal 0. So that's supposed to be a plus sign there. Getting a little sloppy, sorry. So all of that will help with finding our constant, and typically what we know is the initial velocity, and it usually turns out that initial velocity turns out to be the constant. So let's go ahead and say it was thrown down. So the velocity function would be represented by this, and then position integrate, I guess we really should call this something other than C. We'll call that one C1 and this one C2. A little technicality there. We do have different constants. Now, how would we find this?
P of 0, position should be 0, velocity should be 0.
Okay, that would be our P of 0, and say if the object is starting at a top of a building or top of a cliff, 500 feet high, or, well, we've been in terms of meters. 500 meters would be pretty big. How about, let's just go 100 meters. So again, putting in the 0 for t, that'll leave c sub 2 equaling 100. So our position function would turn into this. Now, what we need to think about here, this can be done no matter what we're being asked. And we can find the velocity position function as long as we know what's going on at the beginning, or sometimes the question was how fast was the car moving, when they started to slow down, when they started to brake. Well, that would be, instead of knowing -10 as the initial velocity is just a constant, and you could call it v sub 0 is the initial velocity, then you would have to know something else, like what's happening 5 seconds later, or at the end of the race, or when they stop, something like that. Well, what can we say about an object when it stops?
It has zero velocity.
Okay, the velocity at that particular time would be 0. So that gives us another situation, another known value that you'll be able to set something equal to, set your velocity equal to. Like here, again, if we did not know the initial velocity at the time when it stops, this would equal 0, and then we would also know something about the position. So a lot of different questions that can come out from these. So, but the procedure, again, integrate and then plug in your value to find your constant. And that's, again, how you solve the differential equation given certain information. Okay. Any particular problems, questions about the acceleration, velocity, and position? Okay, on the vertical motion worksheet number 8, it says on the planet Endorcator, I think is how I meant to pronounce that. A rock dropped from a height of 25 feet takes 20 seconds to hit the ground. Assuming the acceleration due to gravity, a of t, is constant on this planet, what is this constant? So, well, again, we're able to start with the acceleration. We just don't know what the value is. We know it's some constant. So let's just call that A. Maybe it's -5, maybe it's -100, something like that. Okay. And let's see, some key points here. One key word, a rock being dropped means what?
Velocity is negative.
V naught is 0.
Okay, the initial velocity is 0. Okay. From a height of 25 feet, takes 20 seconds to hit the ground. Now, that little phrase there tells us a lot of stuff. What's the 25 feet represent?
Why not?
Position at 0.
Okay. So position at time 0 would be 25, p sub 0, y sub 0, whatever you represent that as. And what about the 20 seconds to hit the ground?
Answer ending time.
Okay. 20 seconds would be the ending time.
So the position would be 0.
Okay, the position
Of 20.
of 20
0.
would equal 0. Very good. Yeah, all those little phrases mean something. We just have to figure out what each little word or phrase means in mathematical terms here. Okay. So, well, as we do on all of these, starting with velocity or acceleration, we can find the velocity function. And, well, since the rock is being dropped, the initial velocity, which I think we've done enough of these, we can see that's going to be our constant of 0. So velocity function is a times t, and a again is our acceleration constant. P of t then Well, we'll have a times t squared over 2 plus another constant. Well, what's this constant going to be?
25.
Okay, that's our initial position. So our specific position function, let's say a over 2 t squared plus 25. And now we can use p of 20 equals 0. Well, in this formula, time of 20 seconds, let's say a over 2 times t squared plus 25, that would be the position at 20 seconds, which now we know that position is 0 because it hits the ground. And we have an equation that we can solve for A. So let's see. 20 squared would be 400, divided by 2 would be 200. So 200A equals negative 25. A would be negative 25 over 200, or what, negative 1/8. So the acceleration on that planet would be negative 1/8. What units would we have on there?
I don't know what the problem is with seconds.
Okay. It was given in feet and seconds.
Per second squared.
So feet per second squared. And as you probably remember on previous tests, I am a stickler on units. Make sure you get your units on there. Make sure they're the correct units. This would not be meters per second squared. It would be feet per second squared. Okay? Questions? Now the kind of different type of problem, sometimes I wonder why did they throw this in at this point, but really it doesn't fit too good anywhere. But application of the integration, I guess, is the best place for it. The average value of a function over a certain interval. Let's go through that and kind of explain a little more what it's saying. X squared over 0 to 4 graphically would look like this, and up here we'd have 416 would be our point. So we know the area is the integral from 0 to 4 of the function, and then average value, we say take 1 divided by b minus a. So ultimately it take 1/4 of the area here. Well, antiderivative x cubed over 3 from 0 to 4. Now, be very careful with 0. Many times we plug 0 into the antiderivative, we get 0 for the value. But will that happen every time? Not necessarily. Depends on what function we have. Cosine of 0 is 1. E to the 0 is 1. So be careful what you're plugging 0 in. It's not always going to come out to be 0. Many times it will be, thank goodness, but not every time. So our average value here, let's see, 64 divided by 4 would be 16. 16 over 3, which give us a little better perspective. 5 1/3. Now, calculating it's not that difficult, but do you really know what that value means. What's 5 1/3 mean?
It means if you go over to the y value, it's averaging between.
So that here,
Yeah.
5 1/3.
And if you go over to that line, then down.
Okay. Okay. That creates a rectangle, the height of 5 1/3 and a width of 4 here. Now the graph's a little bit distorted, but this rectangle has the same area that is in this region. That's what average value, one application shows us.
Do you want us to draw a graph?
Now,
That's just
all I want you to do is find the average value. So the answer here would be 5 1/3. Now, they did extend it on the worksheet, basically saying, okay, here's the y value. What x value does that correspond to? But I'm not going to have you do that on the test. You'll have plenty of other things to do. So, questions on average value? Okay, and then several worksheets, several of the videos talked about area, area between two curves, area of a bounded region, and a lot of it dealt with y equals f of x, but the last couple worksheets and videos, he flips it around and says x equals some function of y, and then what's the area? Well, let's start first off. We have some function here and some function here. Let's say this one is h of x and this one is g of x. How would we find the area in that region?
Well, first you want to find your endpoints, so you want to set them equal to each other.
Okay, first of all, we find the endpoints, and it's essentially solving two equations, two unknowns, where both of these are y equals. We can use substitution and basically say, where are the two functions equal to each other?
Are you going to give us one with 3?
Possibly, yeah. We'll kind of work our way up to that. But yeah, it will be a little easier than those on the worksheets. But solving that system, solving this equation here, you should end up with two values. Probably going to be looking at parabolas, x squared, so you will have a quadratic equation to solve. So you'll find x equals some value a and x equals some value b. Well, that'll be what when we calculate the area?
Your intervals.
Okay. So the definite integral will go from a to b, and then we set up the integrand, the inside of the integral, as what?
It'll be h of x minus g of x.
Okay, we can take a little, what I say, a little slice or a local estimate, or turns out to be the top minus the bottom, so whatever h of x is minus whatever g of x is, and that'll calculate that, and that finds your area between those two curves. Now, some of the most tedious work here is once you get into this and plug in the values. A lot of times we'll have some fractions and sometimes not real nice fractions, like we'll have thirds and halves and maybe fourths to have to add together. I'm not going to worry about your fraction mentality, so If you just want to plug it into your calculator and give me a decimal approximation, decimal value is fine. Sometimes I'll say round to the nearest tenth or hundredth or something like that. But if it's not, if I don't state where to round to, typically 2 decimal places is probably good enough. Sometimes it depends on the value. If it's a really small value like 0.0487, well, 2 decimal places probably isn't enough, but most likely 2 decimals is fine. But if you want to go through the tedious work of the fractions and find 55/12ths as your answer, then go right ahead. Might take a little bit longer than you have, but so. Now this is definitely the most basic of these problems, where y equals some function for the top, y equals some other function for the bottom. Some of these we were bounding either by, again, usually a parabola with the y-axis. Okay. What's another way of saying the y-axis?
Y is equal to 0.
No.
Oh.
X is equal to 0.
You got me.
So y-axis would be where x equals 0. So really, in that case, it's a little bit easier. Okay. Well, actually, in that case, well, I've set it up wrong. If it's the y-axis, it would probably be given to you as x equals some function of y. So if it's y equals some function of x with the x-axis, well, the x-axis could be written as the equation y equals 0. So there, you're basically, well, it's the same idea we had here, except one of the functions would simply be 0. And that actually makes life a little bit easier. Okay. But these area problems, it's going to be a lot of algebra and just a tiny little bit of calculus. So hopefully you're kind of looking for shortcuts and figuring out how to do this a little quicker. The more practice you have, the better. Now, question about a bounded region. Some of the problems you were given like 2 or 3 equations. Even one of the probably more difficult ones was bounded below by 1 equation and bounded above by 2 equations. And we'll take a look at one here. So this is number 4 on the summary for area of a region, where bounded below, that means this is going to be on the bottom part, and then above by 2 different lines. So in this case, we're going to have a parabola on the bottom, and just a quick sketch on it. So quick sketch there, doesn't really have to be extremely accurate. Y equals 2x plus 2, 2x, and then 8 minus 4x, 8 will be way up here, and so I'm way off on the graph, but just to give you an idea of what points we need to find, the limits this time, well, it's going to be split into two parts. Now, it doesn't necessarily mean it's exactly half. Sometimes it may end up that way, but for this one, it's going to be, first integral will be from here to here, which this part will be the parabola and the 2x plus 2. So that one we'd find 2x plus 2 equals x squared minus 3x minus 4, and solve that. We'll have what, x minus 6 and x plus 1, which gives us x equals 6. Well, x equals 6 is this one way over here, and we don't need that one, but we do need the negative one. Okay. So our first integration will start from -1, and before we find the upper limit on that, the integrand would be what?
That would be,
2x plus 2 minus x squared.
Okay, take your little slice, and the line is the top part, and the parabola is the bottom part. So 2x plus 2 minus x squared minus 3x minus 4. Now, be very careful. What did I do wrong here? Okay, we're subtracting this entire quantity, so make sure you get parentheses around that, and make sure you multiply that negative through. You can then combine like terms. Couple terms will combine in there, but definitely an easy mistake is forgetting that needs to be multiplied through the parentheses. Okay, then lastly, on our first integral, we've got to find the upper integration limit, which is found by doing what?
2x plus 2 equals 8.
Okay, look at your two lines. That's the intersection of the lines. So 2x plus 2 equals 8 minus 4x. So we'd have 6x equals 6, x equals 1. A little bit off on my graph, but not too bad.
Are we looking at which one are we looking at?
This point right here should be x equals 1. Okay. So that takes care of this part of the bounded region. So then do the similar operations to get our second part over here. We already know the left endpoint of the integrand. I guess we should say plus. We're going to be adding these two integrals together. So here we'll be starting at +1, and then we have to find where the parabola intersects with this line. And this screen's never big enough, but we can set the line equal to our parabola. Again, a quadratic equation. Let's see, add 4x, subtract. And let's see, that one +4 and -3. So x equals -4. Well, that again, that would be this one way over here, which we don't need. And then x equals 3 is the one we do need. So second integration will go from 1 to 3. And then as before, it's going to be the line on top and the parabola on the bottom. So 8 minus 4x minus, once again, our parabola. And then from there, just lots and lots of steps. Not too difficult, but just a lot of places to make little mistakes. A lot of fractions we end up with, but like I said, don't worry about trying to get the common denominator and put it all under one denominator. Get to some point and just plug it all into your calculator and give me a decimal value is fine. So that is probably the most involved. Again, having to find three different intersections of the graphs, and then making sure we get the integrand set up correctly. Okay, and then of course the tedious work of going through the antiderivative and plugging in your values. Questions there? Take a look at one where we're given x equaling some function of y, and this is actually number 2 on more area between two curves. Well, we can again graph this, just kind of give us a feel for what it's going to be like. But graphing something like this, it's going to be a parabola, but instead of opening up or down, it's going to open to the right or to the left. And in this case, it's actually going to open to the left. When y is 0, x will equal 4, and then the where x equals 0, the y-axis, we would find y to be positive, y equals positive or negative 2. So this one is at least somewhat easy to graph, even though it's x equals some function of y. Okay. Now, if this was just between the parabola and the y-axis, then we would be ready to start. But we're also adding another line, so we're cutting this into pieces as well, not limiting it just to the y-axis, so be careful here. And let's see, y equals x plus 2, well, y-intercept of 2, slope of 1, oops, got a little close to my template there. We end up with this as our graph, and to set up our integrand, in this case, we're really looking at a horizontal slice or horizontal local estimate, and we go from the right minus the left, whereas with the vertical estimates, we go top minus the bottom. Well, the right part is actually our parabola, and we're subtracting the line, subtract the quantity of the line. What do we need to put in for the line?
You put it in set equal to x, so it'd be y minus 2.
Okay, correct. We've got to change this to x equals something. So make sure everything, if we're looking at a horizontal slice like this, one part will probably already be in terms of x, but the other part may not be. So solve for x, and the function in terms of y will be y minus 2. So we take the right minus the left, and we are integrating in terms of y. So what's our integral limits?
So we would set them equal to each other.
Correct. Finding these values, well, just from graphing, I think we can get a pretty good idea what that is. Y equals 2 on that one. But what we'll have to do is work with this equation and this one, substitute in x equals 4 minus y squared. well, our x being y minus 2. And again, we have a quadratic, this time with the negative y squared. I'm going to add y squared to both sides and then subtract 4. So, and quadratic, we can factor that. Let's see, plus 3 and minus 2.
Those are your endpoints.
And we would get y equals negative 3 and y equals positive 2, which we already said. We knew positive 2, but this one down here will be at negative 3. So integrate from negative 3 to positive 2. And I'm not real worried about you guys integrating. It's just getting them set up. The integration, yeah, you got to be careful. It takes a little time, but setting them up is usually the hardest part. Okay? Any other questions?